We're jumping straight into a really fascinating paper today. It's called UniCorn, Towards Self-Improving Unified Multimodal Models Through Self-Generated Supervision.
And it tackles, one of the most persistent frustrations in AI right now.
Which is this huge gap, right, between what a model seems to understand and what it can actually reliably create.
Exactly. The authors give it a name, Conduction Aphasia. I mean, think about it. A unified multimodal model, a UMM, it might have perfect comprehension. It can look at an image and critique it flawlessly.
But then you ask it to generate something, and the quality is, well, it's often all over the place.
Right. So UniCorn is their proposed solution. It's a post-training framework that's completely self-contained, no external data, no outside teacher model.
And that autonomy is really the key here. So it works by, splitting the one model into 3 different roles?
Yeah, 3 collaborating agents. You have a proposer, a solver, and a judge. It's basically an internal self-play loop.
And the good stuff from that loop, the high-quality interactions, get turned into training signals through something they call cognitive pattern reconstruction, or CPR.
It's a clever way to bootstrap. You're just distilling the model's own knowledge into better generative skill. And they test it with a new metric called UniCycle.
A text-to-image-to-text loop. That sounds tough.
It is. It checks for real conceptual accuracy, not just pretty pictures.
And the results are pretty clear. UniCorn hits state-of-the-art across the board, DPG at 86.8, and the new UniCycle hard score at 46.5.
It really proves that a model can use its own internal understanding to fix its own generative flaws. It's remarkably efficient.
Okay, so let's unpack that term a bit more. Conduction aphasia. It feels like it gets to the heart of the AGI challenge.
It really does. I mean, the goal is synergy, right? You internalize knowledge with comprehension, and you express it with generation.
So why is that basic handshake still so difficult for these huge UMMs?
It's that functional disconnect. The knowledge is there, it's latent, but it's just not actionable. I mean, we've all seen the classic failure case.
Right, you give it a prompt like a red ball above a blue cube.
And what do you get?
You get the red ball and the blue cube, but they're next to each other or fused together, or the positions are swapped. The spatial relationship is just wrong.
But here's the crazy part.
This is what gets me. You can take that same wrong image and feed it right back into the same model and ask it for a caption.
And it will often nail it. It'll say, a red ball is next to a blue cube. It recognizes its own mistake.
So the critic inside the model, the comprehension part, is working perfectly.
Exactly. The model knows what you asked for, and it knows its output failed, but that knowledge is just a silent passenger. It never translates into the ability to synthesize the image correctly in the first place.
Which is why the paper talks about restoring cognitive symmetry, moving from a passive observer to an active, reliable synthesizer.
And the core insight of UniCorn is, all about efficiency. These UMMs already have really robust image-to-text skills. They're actually great reward models for T2I generation already.
So why not use that strength?
Precisely. Why not repurpose that internal understanding, turn the comprehension part into the very supervisory signal you need to fix the generation part? You just cut out the need for expensive external human annotation.
It's like a form of intellectual jiu-jitsu.
Yeah.
You're using the model's biggest strength to shore up its biggest weakness.
Right.
So if conduction aphasia is the problem, UniCorn is the self-administered therapy. Let's walk through stage 1, this multi-agent sampling idea.
Right, so this is where the model basically has an internal meeting with itself.
Okay.
The single set of parameters takes on 3 different roles. First up is the proposer, and its job is really critical. It generates diverse and, importantly, challenging prompts.
Challenging? Why is that so important? Wouldn't you want to start with easy prompts to guarantee some success?
You might think so, but if you only train on easy stuff, the model never learns from its mistakes or complexities. The proposer really pushes the model by using few-shot in-context learning, dynamic seeding.
So it's not just pulling from some static list?
Not at all. It actually partitions the tasks into 10 different categories. Things like spatial reasoning, counting, specific textures, to make sure the self-play loop is directly targeting the model's current weaknesses.
So the proposer is basically an automated curriculum designer forcing the model out of its comfort zone. That's a huge step up from just using a big external data set.
It is. Then you have the solver. Its job is more straightforward. It just executes the synthesis. It tries to create an image based on the proposer's prompt.
And it does this multiple times, right, to get a variety of output.
A deep search, yeah. They do 8 rollouts for every single prompt, messing with random seeds, different hyperparameters. You get a whole spectrum of quality from, brilliant to absolutely terrible.
Which brings us to the third role.
Yeah.
The judge. It has to sort through all that. How do you make sure the judge is objective and not just, grading its own homework too easily?
Well, it leans on the UMM's strongest skill, that pre-trained image-to-text comprehension. So the caption C pattern. This is about optimizing the inverse mapping. You take the best image, the highest scoring one, and you force the model to predict the original text prompt as the correct answer.
So you're making it recaption its own best work.
You are. It forces that bidirectional link. It makes sure the visual concepts are tightly semantically grounded to the text. It's what helps fix those spatial errors we talked about.
Got it. That makes sense. What about the next one, judgment?
Judgment, J, is about internalizing the reward signal. You're training the model to predict the score, to look at an image and a prompt and say, that's an 8 or that's a 5.
So it develops its own internal sense of quality.
Right, which acts as a diagnostic signal to keep generation stable over time.
And that leaves the last one, reflection. This sounds like the most direct self-correction mechanism.
It absolutely is. With reflection, you take a high reward winning image and a lower reward losing image for the same prompt.
So it's a comparison.
Exactly. You train the model on the trajectory of improvement. You explicitly teach it how to get from that suboptimal losing state to the optimal winning one. This directly encodes the process of self-correction into the model.
A system that fixes itself is one thing, but you need the right metrics to prove it actually worked, which is why they introduced UniCycle. Why weren't the old benchmarks good enough?
Well, because they usually measure comprehension and generation separately, and that can be misleading. It fails to test for conceptual coherence.
What do you mean by that?
You could get a really high score on a text-to-image benchmark with a beautiful image that completely misses a key instruction, like counting or a negative constraint.
I see. So UniCycle forces the whole loop, text to image, and then immediately back to text.
It's a full-circle reconstruction. It tests the alignment and whether any information was lost along the way.
So if I ask for an image of, say, 5 specific animals in a row, it generates the image.
And then you immediately start asking it questions about the image it just made. How many animals are there? Is the cat to the left of the dog?
And an external judge checks if the answers match the original prompt.
Exactly. It's the ultimate fidelity check.
That sounds incredibly strict.
Yeah.
So what's the difference between the soft score and the hard score?
The soft score is just the average score across all the questions, which is useful. But the real test, the one that measures true conceptual coherence, is the hard score.
And that's binary.
It's all or nothing. You get a 1 only if every single question for that prompt is answered correctly. Miss one detail and you get a 0.
Wow. That's a high bar.
It is. And UniCorn crushes it. It gets a hard score of 46.5, where its base model, Bagel, was only at 36.6. That's a huge jump.
So it's not just making prettier pictures. The self-play is actually fixing those deep conceptual flaws. Okay, this is where the rubber meets the road. Let's dig into the benchmark results and what they tell us about knowledge transfer.
This is where you see just how effective the CPR patterns are, especially for tasks that need deep reasoning.
For instance,
take numeracy, the ability to count objects correctly in an image. UniCorn got a staggering plus 13.1 point boost over its baseline.
13 points. That's massive.
It is. 3D spatial reasoning went up by over 6 points. And maybe most impressively, the text subtask on the 1IG benchmark. It jumped by 22.4 points.
22 points on rendering text. That has to mean that captioning and reflection parts are really forcing that tight semantic link between the abstract idea of a word and its visual form.
Absolutely. They're stabilizing the entire process. And then you look at overall instruction following. On the DPG benchmark, UniCorn hits 86.8.
And to give some context on that number.
Well, for perspective, it actually surpassed some powerful closed source models. GPC-40 scored 86.2 on that same benchmark.
So this kind of structured internal self-supervision isn't just a neat trick. It can compete with, and sometimes beat, models trained with massive external distillation.
Which brings us to the ablation studies. This is where they prove just how necessary each piece of the puzzle is.
Right. So what happens if you take away the cognitive patterns, the C, J, and R, and just train on the raw generated images?
These authors call it a catastrophic collapse.
That sounds bad.
It is. The whole latent space just falls apart. The model's core comprehension score, MMEP, plummets from over 1,600 down to about 300.
So that's the smoking gun. It proves that just training on generation without that semantic grounding is actually destructive. The CPR patterns are the guardrails.
They're essential for stability. And the reverse is also true. If you keep the CPR patterns but remove the generation task.
Let me guess, comprehension stays high, but generation doesn't improve.
Exactly. It stalls out. It just confirms that it's a reciprocal process. You need the map from C, J, and R, but you still need the generation step to actually walk the path.
And finally, there's the scaling law, the efficiency story. This is huge for anyone trying to actually implement this stuff.
It's a very favorable scaling curve. Performance just keeps getting better as you add more self-generated data. But the real headline is the efficiency. With only 5,000 self-generated samples.
Just 5,000.
Yeah. With only 5K samples, UniCorn was already outperforming IRG, which was trained on 30,000 GPT-4o distilled samples, and even DALL-E3 on some metrics.
So the quality of the internal supervision is just fundamentally more important here than the sheer volume of external data.
And if we want to connect this back to the theory, it's important to realize these 4 data types, G, C, J, and R, they aren't just arbitrary.
Yep.
They're mathematically designed to minimize the negative log likelihood objective by putting specific constraints on the model.
So captioning is enforcing, bidirectional mutual information.
Right, making sure the concepts flow cleanly both ways between text and image. And judgment creates that internalized preference, which is like having a built-in discriminator running continuously.
And reflection is the most explicit part, teaching the actual trajectory of self-reflection.
Guiding the model from a bad state to a good one. The whole thing is it's a framework for explicit error correction. It's the cure for conduction aphasia.
But it does raise a question about the scope of the improvement. The paper is pretty clear that while generation got way better, the core understanding metrics didn't really improve much, they were just preserved.
And that's the main limitation right now. The framework is single turn, and it's really focused on refining the output. It uses the existing understanding, but it doesn't really deepen it.
So future work could explore multi-turn self-play.
Exactly. Something that allows for the co-evolution of both understanding and generation at the same time.
And there's also the computational cost. This proposer-solver-judge loop, while it saves on data, it does add overhead that needs to be streamlined.
For sure. And we should also point out, it's not a silver bullet. Even UniCorn still struggles with some of those classic, really hard challenges.
The precise counting of many objects
or the semantic complexity of negation. Telling it to draw a scene without a cat. That kind of abstract constraint is still a massive hurdle, even for a self-correcting model.
So those failure cases are a good reminder that there are still some very deep architectural boundaries we haven't crossed yet.
But the bottom line is still incredibly positive. UniCorn successfully weaponizes a model's own latent comprehension and turns it into an explicit, actionable, self-supervisory signal.
It really does prove that a single model can, in fact, autonomously learn to fix its own biggest flaws.
And it validates a much more efficient path forward for all of us.
So what does this all mean for you, the researcher or engineer working on these foundation models? Well, if a unified model can successfully train itself just by leveraging its own internal ability to understand what a good image should look like, does this mean the future is less about petabytes of external data and maybe more about the cognitive integrity, the structure, and the efficiency of a model's own internal self-optimizing architecture? That's a challenging prompt for all of us to consider.